Hello again, welcome to this series of videos on capacitors. What I've done now is I've downloaded a PHET capacitor lab where we can play around with the various parameters of the parallel plate capacitor and see what affects the capacitance. So I'm going to turn on my meter for capacitance. I'm going to turn on a meter for the charge on the, and I'm also going to check on the electric field lines. So I have a battery connected to a parallel plate conductor, and if I increase the voltage, you see that I have an excess of negative charge on the bottom plate, excess of positive charge on the top plate, and therefore I have a capacitance. So this is, my meters are telling me I have 0.13 times 10 to the negative 12 coulombs of charge here. I have 0.189, let's see, get the voltmeter out. I have 1.5 volts, therefore I have a capacitance. I have a store of charge. And you can see, because I have negative charges on this side and positive charges on this side, I have an electric field created. So first of all, let's see what happens when I bring the plates closer together. Okay, let's just do that again. If I draw them further apart, let's see the effect on capacitance. So when the plates have a larger separation, the capacitance decreases. When the plates have a shorter separation, the capacitance increases. Okay, what about if I increase the area? By increasing the area, I increase the capacitance. By decreasing the area, I have a smaller capacitance. Okay, so we found two factors which affect the capacitance. Now, a final factor which affects capacitance is introducing something called a dielectric. So in between these two plates at the moment, we can imagine we have a vacuum. But if we were to introduce another material in between the two plates, which is not a conducting material but an insulating material, this is called a dielectric. Let's see what happens. Right now we have the battery still connected. What happened? Well, let's just go before the dielectric, low capacitance. After the dielectric, we increase the capacitance. And the reason why that's happened is, you can just about see it, but inside the dielectric here, the material has become polarized, which means that some of the negative charges on the bottom have been cancelled with some of the positive charges on the polarized dielectric. Means that we can add store more charge on the bottom plate. Likewise, the negative charges here cancel, or mean that we can store more positive charge on the top plate, meaning we can increase the capacitance. If I just disconnect the battery here for a second, and so we have a fixed amount of charge, if you like, on the plates. We can't draw any more charge off the battery. Let's see what happens when I introduce the dielectric now. The capacitance has still increased. Why is that? Well, if you look at the electric field before, and electric field strength is a measure of, or the electric field strength is directly proportional to the potential difference. When I introduce the dielectric, the electric field strength is reduced because I have a net lower electric field due to the polarized molecules of the dielectric, which means I have more charge per unit potential difference and therefore a greater capacitance. So in either case, when I have the battery connected or disconnected, by introducing a dielectric, I can increase the capacitance.